The Thor missile system is an all-weather low to medium altitude, short-range surface-to-air missile system designed for engaging airplanes, helicopters, cruise missiles, precision-guided munitions, unmanned aerial vehicles and short-range ballistic threats. Originally developed by the Soviet Union under the GRAU designation 9K330, the system is commonly known by its NATO reporting name, SA-15 Gauntlet. A navalized variant was developed under the name 3K95 Kinzhal, also known as the SAN-9 Gauntlet. Thor was also the first air defense system in the world designed from the start to shoot down precision-guided weapons like the AGM-86 ALCM. Moving with the troops, Thor can detect targets itself, for shooting need a short stop. Development. The development of the Thor missile system started on 4 February 1975, in response to the directives of the Central Committee of the CPSU. Initiated as a successor to the 9K33 OSA, development on the land-based version was conducted in parallel with a navalized variant of the system, to be installed on a number of upcoming ship classes, including the Kirov-class battler cruisers, and retrofitted onto older ships. Responsibility for development was given to the Anti-Design Bureau headed by VP Efremov, the missiles designed by MKB Faglander P.D. Grushin and the Altair Design Bureau headed by S.A. Fadue responsible for development of Kinzhal. All the developers and manufacturers of the Thor missile system unified into Almaz-Anti in 2002. Mobility is 3 minutes, can be transported by any transport. The reaction time of the original Thor 8.7, standard, /10.7, if there was a in motion, seconds. The project was given strict design specifications to meet. Thor had to provide extended detection and tracking of fast, low radar cross-section targets and be capable of quickly and efficiently dealing with massed air raids, whilst providing a high degree of automation and integration with other air defense assets. In order to meet these demanding specifications, the designers used a variety of new technologies, including advanced phased array radar for improved detection and tracking performance, enhanced digital information processing, and vertically launched missiles to improve reaction time and increase the number of readily available munitions. After a period of testing and evaluation between December 1983 and December 1984, the land-based system was accepted into service on March 19, 1986. Despite starting testing earlier than its terrestrial counterpart, the naval variant, Kinzhal, had a more protracted development. After an extended testing period using a Project 1124 Grisha-class corvette anti-ship missiles in 1986, Kinzhal finally entered service in 1989. Improvements. Even while the Thor was being introduced into service, work started on improving the system, resulting in an enhanced version, the Thor M1. Many improvements over the original system were made. These included the addition of a second fire control channel, allowing two targets to be engaged at once, as well as upgrades to the optical tracking system and computer equipment. ECM protection and warhead design were also modified, as was the ammunition handling system. State tests, conducted between March and December 1989, showed that the result was a system which could engage more targets in a shorter time frame with reaction times reduced by over a second and an increased probability of target destruction. The M1 was introduced into service in 1991. Further modifications occurred as a response of insight gained from the 1995 NATO bombing in Bosnia and Herzegovina, resulting in the Thor M1-1, or Thor M1V, which offered improved network connectivity and ECM functions. Significantly increased the probability of hitting any target. In 1993, in the interference conditions was able to shoot down small-sized rocket. Upgrades have continued over the lifetime of the system, with developer Almaz-Anti unveiling the newest incarnation of the Thor missile system, the Thor M2E, at the MAKS Air Show in 2007. The latest variant features improved fire control radar coverage, and 4 guidance channels, allowing up to 4 missiles to be guided at any one time. The Thor M2E also offers the option of a wheeled chassis, as well as a new digital computer system and all-weather optical tracking system. Tor M1-2U entered service in the framework of the State Defense Order at the end of 2012. This system is designed to destroy aircraft, helicopters, wind drones, missiles, and other elements of precision weapons, flying at medium, low and very low altitudes in all weathers. The system is able to hit 4 targets simultaneously at a height of up to 10 kilometers. Its crew consists of 3 people. Description: the closest foreign analogues to the Tor, in function and operation, are systems like the British Rapier missile and French Crotale missile systems. Analogues significantly worse than Tor. All 3 systems are mobile and self-propelled, Tor using the 9A330 combat vehicle, which carries a crew of 4, and acts as an autonomous transporter, launcher, and radar unit, or TLAR. The 9A330 is based on the GM355 chassis manufactured by MMZ, the Tor M1 using the improved GM5955. Like Rapier and Crotale, in addition to the tracked vehicle, there are also static and towed versions of the Tor, as well as a wheeled one. Arranged in a similar fashion to the previous 9K33 OSA and 9K22 Tunguska air defense systems, Tora Euro unregistered trademark STLAR features a turret with a top-mounted target acquisition radar, and frontal tracking radar, with 8 ready-to-fire missiles stored vertically between the 2 radars. The target acquisition radar is a 3D F-band pulse Doppler radar, equipped with a truncated parabolic antenna, and a mechanically, later electronically, scanned in azimuth with a 32-degree sector view, and has an average power output of 1.5 kW, which provides a maximum detection range of 25 km/16 mi. For reference, a McDonnell Douglas F-15 at an altitude of 6 km has a detection probability of 0.8 at this range. The electronic HART unregistered trademark of the system is a digital fire control system, which allows detection of up to 48 targets and the tracking of 10 at any one time, and integrates IFF functionality. The IFF antenna being mounted above the search radar. The target engagement radar is a G-band H-band pulse Doppler radar with an electronically scanned phased array antenna. The radar is classed as a thinned array incorporating only 570 phase shifters and uses linear polarization. The radar has an average power output of 0.6 kW providing a maximum detection range of 20 km/12 mi. An F-15 type aircraft had a detection probability of 0.8 at this range. Originally Tor could only engage 1 target at a time, and with only 2 of its missiles. Later variants of the Tor system incorporate additional fire control channels, as well as improved fire control computers, allowing the system to engage 2 and then 4 targets, whilst simultaneously guiding up to 4 and then 8 missiles. There is also a small antenna on the top of the target engagement radar to communicate with missiles after launch. Together these radars carry the NATO reporting name scrum-half. To reduce the dimensions of the vehicle, the target acquisition radar can be folded down horizontally when traveling, and the tracking radar can partially rotate away from vertical. To allow engagements in the ECM-heavy environment that is the modern battlefield, the 9K332 is equipped with an optical tracking system, complementing the main radar. As a fully mobile system, the Tor is capable of acquiring and tracking targets while the TLAR is moving. Due, however, to the interference with launch operations while on the move, missiles can be fired only when the system is in a stationary position. Once set up, the reaction time is described as 5–8 seconds, depending on the variant. However, reaction time is somewhat longer whilst in motion and firing in short halts. To facilitate this mode of operation, an auxiliary power unit is fitted so that the main engine can be shut down while the radar and missile system continue to operate when stationary, enabling long periods of readiness. The digital computers allowed for a higher degree of automation than any previous Soviet system of its type. Target threat classification is automatic and the system can be operated with little operator input, if desired. The high-performance computing system combined with a phased array radar are the main reasons for the system's high degree of accuracy, ability to intercept small, fast and highly maneuverable targets, and the very fast reaction times of the system. It is equipped with NBC protection. Reflecting the complex nature of system, the price per unit was quoted as $25 million in 2007. Typically, a battery of 4 Thor vehicles is accompanied by the mobile AGM command center, provides automatically interaction with the SA-15, 8, 13, 16. It allows for efficient allocation of tasks between the individual Thor M1 crews and allows each TLAR to be linked into a wider air defense system, thereby increasing target detection range and reaction time. Thor vehicles is accompanied by the mobile Pollyanna D4 provides automatically interaction with the SA-15, 17, 19, 23. Thor M1 receiving commands from AGM-Pollyanna D4 can shoot down targets in the range of 0 to 84 degrees. Thor M1 system can operate in a pair, then the angle of observation was 0 to 64 degrees. 3K-95 Kinzhal. The 3K-95 Kinzhal is the naval version of the Thor missile system developed by Altair and has the NATO reporting name SAN-9 Gauntlet. Using the same 9M330 missile as the land-based version, the system can be mounted on vessels displacing over 800 tons and is known to be installed on Admiral Kostov-class aircraft carriers, Kirov-class multi-mission cruisers, Udaloy-class anti-submarine destroyers and new Strashimi-class frigates. The naval version of the later Thor M1 is known as the YOZH, while the export version of the Kinzhal is known as Kleinok. Stored within rotary VLS modules, the missiles are clustered into launchers comprising 3 to 6 modules, 64 or 192 missiles, and mounted flush to the deck. Each module has up to 8 missiles stored ready to fire. During firing, the missile is cold-launched using a gas catapult before the launcher brings the next round to a firing position. Fire control is handled by the 395 multi-channel FC system composed of 2 different radar sets, a G-band target acquisition radar and a K-band target engagement radar, that handles the actual prosecution of a target. Using 2 top-mounted, mechanically scanned, parabolic target acquisition radars, the fire control system provides a 360-degree field of view, as well as IFF. The target engagement radar is an electronically scanned phased array antenna of the reflection type mounted on the front of the fire control system with a 60-degree field of view. Much like its land-based sibling, the target engagement radar can track and guide 8 missiles on up to 4 targets at once and is effective to a range of 1.5 Euro 12 km and an altitude of 10 Euro 6000 m. The system has a reaction time of 8 Euro 24 seconds, depending on the mode of operation, and is managed by a crew of 13. Additional missile guidance antennae can be seen around the fire control system, and the 3K-95, like the upgraded Thor launchers, is equipped with a secondary infrared guidance system. The 3A-95 can also provide fire control information for the vessel's AK-630 close-in weapons systems, providing a second line of defense should anything penetrate the missile layer. Variants: 9K330 Thor with the 9M330 missile, minimum range 2 km, introduced in 1983, 9K331 Thor M1, introduced in 1991 with the 9M331 missile, with greatly improved missile accuracy and the ability to engage 2 targets simultaneously, minimum range 1.5 km. Thor M1V has a protection against spoofing. 9K332 Thor M2, in service since 2007, protection against spoofing. The reaction time is 7 seconds, fully automated. The ability to engage 4 targets simultaneously. ADMS Thor M2 are currently produced at OJSCI's Hevsk Electromechanical Plant at Kipola. Thor M2E anti-aircraft missile system with a fighting vehicle on Caterpillar chassis. In the composition includes the Fighting Machine 9TH-331 THOE and Anti-Aircraft Missile Module 9 THO-334 with 4 anti-aircraft guided missiles 9 THO-9331. The crew of 2 persons. The fully is automated. Thor M2K anti-aircraft missile system with fighting machine on a wheeled chassis. Chassis developed by the Belarusian enterprise AMZKTA. In the composition includes the Fighting Machine 90H-331 and Anti-Aircraft Missile Module 9THO-334 with 4 anti-aircraft guided missiles 9THO-9331. Characteristics: the affected area, range 1 to 15 km, height, from 0.01 to 10 km. The time of reaction, 4.8 s, max target speed, 700 m/s, number of simultaneously engaged targets, 4, maximum overload of the missiles, 30, flight speed of the missiles, 700. 800 m/s, minimum target RCS, 0.05 m2, guidance system, anti-jamming, commands via radio, number of target channels, 4, the number of missiles on combat vehicle, 8, year of development, 2008, the crew of 3 persons, cruising range of 500 km, Tortho 2 THSH-THOE created in modular design, to accommodate various types of chassis. In the composition includes, an autonomous fighting machine 90H-331 THO-1 and anti-aircraft missile module 9THO-334 with 4 anti-aircraft guided missiles 9THO-9331. At MAKS 2013 was presented on the chassis of the Indian Tata. The affected area expanded to height, 10 km, distance, 15 the crew of 2 persons. Chance to destroy any target as a minimum 98%. Significantly improving penetrating power of fragments of warhead. The fully is automated. Modules weighing 15 tons are installed on ships of the Russian Navy. Ammunition Tor M2 missile 9M331 8 or 16 missiles 9M338. The affected area expanded to height, 10 km, distance, 16. The maximum speed of the rocket 1 km per second. Time for a short stop for the start firing reduced to 2 seconds. 9M338 have already produced. Missiles, weighing in at 167 kg, the 9M330 missile is 3 am long, carries a 15 kg warhead and has a peak speed of around Mach 2.8. Utilizing command guidance and radar-controlled proximity fuses, the missiles can maneuver at up to 30 gs and engage targets flying at up to Mach 2. Cold-launched, the missiles are propelled out of the vehicle before the solid-fuel rocket motor fires and the gas dynamic maneuvering system turns them toward their target. Missiles can also be fired against surface targets. Each missile is a sealed round, stored in 2 groups of 4. Engagement range is up to 12 km with minimum range varying between 1500 to 2000 m, depending upon version and an effective altitude of 10 to 6000 m. Kill probabilities for later versions are quoted as 0.92-0.95 against aircraft, 0.80-0.96 against helicopters, 0.60-0.90 against cruise missiles, 0.70-0.90 against precision munitions, 0.90 against UAVs. A new 9M338 missile has been developed by Almazanti offering improved range and precision. Its smaller size also enables the modified Tor M2 to be equipped with 16 missiles as opposed to the original 8. Combat history. In a press conference regarding the 2008 South Ossetia War, Russian Defense Ministry spokesperson Anatoly Nogovitsyn speculated about the use of the Tor missile system by Georgia against attacking Russian aircraft. The system suggested as a possible cause of the loss of a Tu-22 Mr. strategic bomber, shot down by Georgian air defenses while on a reconnaissance mission during the conflict. While the loss of the bomber has also been attributed to Bike M1, which Georgia obtained from the Ukraine in 2007, if the loss can be attributed to Tor, it would be the first time the system has seen combat use. Operators. The Headquarters 17 is the reported Chinese designation for the Tor missile system, which is replacing the Headquarters 61. There is no confirmation that China is currently manufacturing its own licensed copy of the Tor system. In 1996, China ordered 14 Tor M1 missile systems from Russia which were delivered under contract in 1997. In 1999, another contract for 13 Tor M1 systems was signed between Russia and China. Delivery of the systems took place in 2000. Russia has delivered an undetermined number of Tor M1 systems to the Islamic Republic of Iran amid protests from the United States. It is suspected that at least 29 such systems have been transferred along with service contracts with an approximate value of $700 million USD. In Azerbaijan, several batteries of Tor M2E, a Belarus 2 batteries delivered as of January 10, 2013. Third battery delivered in 2013. In future these missile systems will possibly substitute the SA-15 Gauntlet, SA-11 Gadfly, SA-8 Gecko, 120th Anti-Aircraft Missile Brigade 12 Tor M2E. China, 35. 69th SH-331 A Tor M1A, as of 2012 military balance 2012 page equals 235, A Cyprus, 6, A Egypt, 16, A Georgia, 20, A Greece, 25, A Iran, 29, A Russia, 172. A Ukraine, unknown, A Venezuela, 12, A Morocco, unknown, see also, 9K-22 Tunguska, Pantsir S-1, Bike Missile System, references. External links, Almazanti, Tor Design Bureau, Kippel, Tor Manufacturer, Federation of American Scientists page, SA-15 Gauntlet/9K331 Tor, Global Security, TOR M1 Update, demonstration of Tor M2E on August 20, 2009, video, 2009 MAKS Airshow, NIEMI press release.